Okay, so we're just going to review metric system and converting units. Again, this is all review, but really important in physics. Converting units just happens all the time. So, a quick little review. One thing I want you to note as far as converting units go, when we're talking about length, there's certain units that we tend to focus on. So we tend, when we're measuring the length of things, focus on kilometers, meters, centimeters, and millimeters. Those are the four that we focus on. We really don't use hectometers and decameters and decimeters. They're just really not used typically. Time, just a little reminder when we're talking about time, there are 3,600 seconds in 1 hour and 60 seconds in a minute. So I'm going to complete this conversion factor with you. When I save my Word files into this app that I write on, it sometimes does some weird things. So I'm missing the conversion factors, but you'll just be able to fill yours in. I'm going to have to do a little bit of erasing because I just don't have room because it's not typed in for some reason. So how many millimeters in a centimeter? My brain automatically, because I'm visual, I always think of rulers and meter sticks when I do conversions. So I think of a ruler and I know there are 10 millimeters in a centimeter. Also, here we're looking at 1 0, right? Difference, so 10. So to complete the conversion factor for every centimeter, there are 10 millimeters. And do remember that line means divided by. Okay. Meters in a kilometer. So we're going from here to here. There are 1,000 meters in a kilometer. So 1 kilometer, 1,000 meters. Centimeters in a meter. So again, I visualize the meter stick and I think of a ruler with its, 30-ish centimeters. So logically, because we're always going by factors of 10, there would be 100 centimeters. So 100 centimeters per 1 meter. And now I'm officially out of room, so I'm just going to erase that because you already took it down, hopefully. And we'll just finish up. How many millimeters in a kilometer? Well, we're going to start here. Remember, there's a 0 for every, because we're looking at factors of 10. There's a 0 we add as we move. So 1, 2, 3, 4, 5, 6, all the way up to kilometers. So 1, 2, 3, 4, 5, 6. So for every kilometer, we have 1 million millimeters. Okay, we can now use these conversion factors to convert our measurements. So here our first one, and of course yours doesn't look, I don't know what happens, but yours doesn't look like this. You have this first example, 92 centimeters to millimeters. Well, we know that 1 centimeter, if we look at our conversion factor, 1 centimeter over 10 millimeters, but we're going the other way. So we're going to times that by 10 millimeters per centimeter. Okay, and so by multiplying that, this cancels and we get 920 millimeters. Of course, mine just gave you the answer. I don't know what's going on there. But anyway, so you're just going to continue on with the rest of those in that same fashion. Using conversion factors for time. Show all conversion factors. Again, it just makes things nice and neat. I really like to see what I did up here, which is the cancellation of units, right? You know that a centimeter divided by a centimeter is just, it's gone, right? They cancel. That was, as conversions get a little more complicated, showing that step where you're canceling units is just nice to see, and it just helps you make sense in your head. So if you can use conversion factors here, that would be lovely. Wow, I wonder what that is. I'd have to go back and look on the sheet. But give these a try. If you have any troubles, just ask. Now, standard form, again, you should have covered this in grade 9. Standard form is something we use to represent really large numbers or really small numbers. So just a little reminder, when the exponent is negative, you are going to move the decimal to the left that many places. Okay? If the exponent is positive, you are going to move the decimal to the right that many places. So this represents right here a large number as opposed to this one, which is a small one. Okay, and then you're going to convert back into scientific notation. So again, your large numbers, you're going to place that decimal in there. So between the 4 and the 5. And your large numbers, the exponent should be positive, and your small ones, the exponent should be negative. So just go ahead and try those. If you have any questions at all, just ask. And we will move on with reflecting light in plane mirrors tomorrow.